What if the universe's ultimate speed is not the marvel we imagine, but a cosmic disappointment? But how big are these distances, really? To grasp the full scale, we need to follow a single beam of light on its impossible journey. Picture something hurtling through space at nearly 300,000 kilometers each second. That is quick enough to circle the globe 7 times in the blink of an eye. It sounds unbeatable, almost magical. To put it in perspective, if you could keep up that pace, you could travel from New York to Tokyo in less than 100th of a second. It is the sort of speed that seems to belong to science fiction, not reality. Is it possible that even light speed is not enough? If the fastest traveler in the universe cannot conquer these cosmic chasms, maybe interstellar journeys are nothing but dreams. The future of space exploration and the very hope of touching other worlds might be slipping away before it ever begins. History is full of explorers staring into the unknown and feeling both excitement and despair, but never before has the chasm been so absolute. Yet even this extraordinary pace is dwarfed by the staggering scale of the cosmos. Light, the fastest thing in existence, still crawls across the vast gulfs between stars. When faced with these immense distances, what once seemed impossibly swift suddenly feels painfully sluggish. Imagine sending a signal to a spacecraft orbiting Neptune. Even at light speed, your message would take over 4 hours to arrive, meaning a round-trip conversation would last the better part of a workday. How far is far when you travel at the speed of light? The truth is more unsettling and awe-inspiring than it first appears. Picture yourself hurtling through the cosmos as fast as physics allows, yet still inching forward across the vast emptiness. It is like running the fastest marathon possible, only to find that the finish line is on another continent, across an ocean you can barely comprehend. Proxima Centauri, the closest star beyond our sun. It is over 4 light-years away. Even if you could move at light speed, the trip would last more than 4 years, longer than high school, just to reach the nearest star. For comparison, the Apollo missions took only 3 days to reach the moon. A journey to Proxima Centauri would be like boarding a ship at the beginning of high school and only arriving at graduation, with no stops along the way. Within our own solar system, the immensity is still staggering. Sunlight takes more than 8 minutes to reach Earth. Every sunrise we see is 8 minutes old, a delayed memory of our star. If the sun were to vanish this instant, we would not know until almost 10 minutes later. The delays are not just trivia. They are reminders that the universe speaks to us with echoes, not live broadcasts. In these terms, our solar system alone feels nearly boundless. The Voyager 1 probe, humanity's furthest ambassador, has been traveling for over 4 decades, and it is just over 22 light hours from Earth. Barely a day's journey for light, but an entire lifetime for a machine. Mars, depending on its orbit, can sit as far as 20 light minutes from us. That means any command sent to a Mars rover today would be received by the rover 20 minutes from now. Each message sent to rovers on Mars is like tossing a note into a slow-moving river. By the time it is read, the world has changed. Pluto is farther still, more than 5 light hours away. Imagine an emergency on a spacecraft at Pluto. Help sent from Earth would arrive hours after the crisis began. Yet, our longing to explore has never been bound by practicality alone. Confronted with these cosmic barriers, we must ask, what can humanity do when even light is outpaced by the universe itself? Beyond, the Andromeda galaxy waits 2.5 million light-years away. Even a photon would not arrive until entire civilizations had risen and vanished. To put that in context, 2.5 million years ago, the first members of the genus Homo were just appearing on Earth. If our ancestors had fired a laser beam at Andromeda, it would only now be arriving. Now, widen your gaze. The Milky Way, our galactic home, unfurls across 100,000 light-years. A beam of light would need 100,000 years to cross it. That is longer than all of recorded human history by a factor of 10. If you began your journey at the dawn of the last ice age, you would only now be a small fraction of the way across. With distances like these, the dream of interstellar travel crashes against a harsh truth. Space is so immense, even light seems slow. The speed of light, once a beacon of hope, becomes a stark reminder of how confined we truly are. Our universe is not simply large, it is almost unfathomably fast. The universe is not only vast, it is escaping us, expanding faster than our wildest ambitions can pursue. Our observable cosmos stretches for nearly 93 billion light-years, yet every moment, that edge rushes further out. No matter how ingenious our technology becomes, there are realms already vanishing beyond our reach, receding faster than light itself, sealed away forever by the relentless swelling of space. Suppose we somehow build a ship that approaches light speed. Einstein's theory of relativity then sets its own trap. Time for the crew would crawl compared to clocks on Earth. A journey to a distant star and back might feel like years for those aboard, but centuries or even entire millennia would slip by on Earth, making such a mission a one-way leap into the future. The famous twin paradox predicts that an astronaut returning from a near-light speed journey would find everyone they knew long gone. Then come the physical threats. At near-light speeds, the tiniest grain of dust transforms into a lethal missile, striking with the force of a bomb. Radiation from deep space would batter the ship, and lurking hazards, rogue black holes, sudden gamma bursts, could end the mission in an instant. A collision with a pebble at those speeds would be catastrophic, releasing as much energy as a small nuclear bomb. Yet even this idea crashes against a brutal energy wall. To accelerate a single ship to even a tenth the speed of light would consume more energy than all of humanity can generate in many years. The faster we try to go, the steeper the cost becomes, rising to levels that dwarf the output of our entire planet, or even our sun. For instance, to send a modestly sized spacecraft to Proxima Centauri at 20% the speed of light, calculations suggest we would need to generate and direct an amount of energy roughly equivalent to the annual output of all human civilization for decades. Yet, despite these daunting barriers, our longing to explore endures. Is there any hope of breaching these cosmic limits, or must we accept them as humanity's final frontier? Even if we could shield against the universe's fury, another barrier looms: the psychological cost. Months, years, or entire lifetimes spent in isolation, haunted by the knowledge that the universe is a place of almost unthinkable emptiness. Imagine a crew venturing into the dark, knowing they may never see Earth again, or that the world they return to could be unrecognizable. Throughout history, explorers have faced loneliness and risk, but never on this scale. These are not just technical puzzles. They are existential walls. We risk more than a failed mission. We risk losing our sense of what is possible. Each limit we meet seems to shrink our dreams of reaching the stars. It calls to mind the ancient mariners who feared sailing beyond the horizon, except this time the horizon is not just unknown, it is unreachable. Is there really a hidden passage through the cosmic abyss, or are we only chasing dreams? Science fiction seduces us with visions of warp drives and wormholes, where space can be twisted or folded to bring distant stars within our grasp in a heartbeat. These ideas thrill us because they seem to promise a way to rewrite the rules, making the impossible possible and turning the universe into a place we might truly explore. But physics, so far, offers only equations on paper. The price? They require negative energy, or exotic matter, strange materials that have never been found in our universe. No experiment or observation has uncovered even the faintest trace of the negative energy needed to make such shortcuts a reality. Not even the Large Hadron Collider, the most powerful particle accelerator ever built, has found evidence of these exotic phenomena. All these sparkling possibilities remain locked inside the fortress of theory. For now, they're chalkboard fantasies, out of reach for any real-world engineer or astronaut. The cosmic abyss stays untouched, with the speed of light guarding its secrets like an unbreakable law. Just as alchemists once dreamed of turning lead into gold, we now dream of bending space to our will. Yet, even within those limits, humanity's drive to explore persists. The question becomes, can we find meaning and wonder within the boundaries that the universe has set? Imagine, just for a moment, that we did discover a way. The dangers would be staggering. Theoretical models warn that warp bubbles or wormholes could be wildly unstable, collapsing without warning or causing disastrous side effects. They might tear holes in causality, spark time paradoxes, or even destroy whatever attempted the journey, and possibly much more. Some calculations suggest that opening a wormhole could release enough energy to obliterate entire planets. Placing our hopes in untested physics is a risky bet. It could mean endless disappointment, chasing illusions instead of real progress. Maybe it even blinds us to the true spirit of exploration, the courage to meet reality on its own terms, with all the limits that entails. History is filled with examples of humanity's hubris, like the quest for perpetual motion, where dreams clashed with the immovable laws of nature. The universe taunts us with impossible distances. We dream of crossing the cosmic sea, but the speed of light, no matter how blindingly fast, remains an unbreakable wall. Every law of physics insists, no ship, no signal, no mind can ever race beyond that limit. For all our ambition, the stars stay heartbreakingly out of reach. Some of humanity's greatest discoveries happen without ever leaving the ground. Galileo, with his simple telescope, transformed our understanding of the cosmos from his backyard. The great observatories, like Hubble, have shown us galaxies billions of light years away, without a single human leaving Earth's surface. Radio telescopes have mapped the cosmic microwave background, revealing the universe's earliest moments. But boundaries are not just obstacles, they are invitations to deeper questions. Every photon from a distant galaxy is more than a faint relic. It is a messenger carrying secrets across millions or even billions of years. When we gaze upward, we do not simply see pinpricks of light. We witness echoes from the birth of everything we know. Each glimmer in the night sky is a time machine, showing us the universe as it once was. Your own curiosity is the launchpad. Here is how you can take part in our shared cosmic adventure. Exploration does not always require rockets or rovers. The most daring journeys are often those of curiosity and imagination. Even when our bodies remain anchored to Earth, our minds can chase mysteries no spaceship could ever reach. Each observation, each question, pushes against the edge of the possible. The physicist Richard Feynman once said, "The pleasure of finding things out is a reward in itself, a journey as profound as any trek across space." There is always a new mystery to chase, a new idea to unravel, and you do not need to leave home to join the journey. Citizen science projects invite people to help classify distant galaxies, search for exoplanets, or even help decode signals from space. You can participate in the cosmic quest from your own desk. If we define exploration only as physical travel, we risk missing the greatest adventure of all, the invisible odyssey of understanding. Our most profound frontiers lie within, in the daring of our questions, the boldness of our wonder. The universe may keep us distant, but our imagination is boundless. From the mathematics of black holes to the philosophy of time, every new insight is a step into the unknown. Why does the universe have a speed limit? What makes light so special? Follow your curiosity. Read books, watch documentaries, join online forums, or visit planetariums. Try out stargazing. Find a dark sky, look up, and realize you are seeing the distant past. You are a cosmic explorer already. Every question you ask takes you one step further into the unknown. Share what you learn, inspire others, and keep the conversation alive. Science advances not just in laboratories, but in the wonder sparked around kitchen tables and in classrooms everywhere. Once, the speed of light was our wildest dream. Now, it stands as a wall, a relentless, silent barrier between us and the endless expanse. But that wall is not only an obstacle, it is an invitation. It dares us to peer deeper, to chase new questions, and to imagine worlds just out of reach. Each time you look up and wonder what lies beyond, you are part of this legacy. Every question, every late-night conversation, every experiment is another step, if not through space, then across the frontier of imagination. We may never outrun the speed of light, but there is no limit to our curiosity. For centuries, our curiosity has burned brighter because of our limits, not in spite of them. The fact that we cannot yet touch distant stars makes our search more urgent, our questions sharper. When we treat our boundaries as inspiration, we keep alive the same restless spark that sent humans across oceans and into the heart of the atom. The explorers of the past were not discouraged by the limits of their ships. They built new ones, or found new ways to look further. So let's embrace the barriers, not as failures, but as fuel. Ask your questions, share your wonder, because together, by daring to wonder, we keep the edge of discovery alive. The universe's speed limit may never bend, but our imagination can always leap beyond.